the energy level, right? Just so I can keep them straight. And then the next, then I put in, I got 6 more, I put 2p6 in there. So I go to the next one.
3s.
I'm gonna change the color so I keep them straight. Okay, so the next one would be 3s2, 3p6. That's 8, but it'll hold more. So it'll be, the next one will be 3d, and that goes up to 10, which will make 18, right? Then you go to the next one.
4s2.
4s2, 4p6, 4d10, 4f14. And it keeps on going, but we don't have to go past 14 to cover all the elements we know. F is high if we need to go. The next one, I mean, probably a G, and it holds, 18? Maybe it's not G, I don't know what it is. I read a book about it one time, it's like, oh my God. Alright, so what we're going to do is we're going to make our little chart now. We're going to take these values here, and we're going to put them in an order. I think I'll go to the next page. Well, so I'll write it down. 1s2. That's the first one, right? Then I go 2s2, 2p6. Then I go 3s2, 3p6, 3d10. Then I go 4s2, 4p6, 4d10, 4f14. Does everybody understand where I'm getting those values?
Yes.
So now I'm going to reverse it. I'm going to keep the number, the orbit. I'm going to change the number for the orbit, but everything else is going to stay the same. But I'm going to go reverse. So now I would have 5s2, 5p6, 5d10, 5f14. I'm going to cut it down by 1. 6s2, 6p6. That doesn't look right. 6p6, 6d10. Cut it down by another one. 7s2, 7p6, and the last one's 8s2. Should be able to write that. If you just practice a couple times, it comes pretty easy. You just have to remember S2, P6, D10, and F14. So now the order of filling. Oh, the easiest way if you have trouble is to start down here, and it goes there. You can start at the top if you want to, except the first 2 are by themselves. And I'll put a little arrow here. You always go in this direction. Start here. Every time you start with a new element, that's where you start. So how many of you feel comfortable drawing that out? If you can do that, then you should be able to do the electron configures. What we're going to do is we're going to write these numbers until the point where we get the number of the electrons that that element contains. If you follow this pattern, what's neat about it is, let me copy and paste it first, and I'll come back and scribble it up. Copy. Paste. So now I'm going to go back. What's neat about this, the first one, what's the maximum number of electrons you can put in the outside shell for the first one? 2. Octet, let me write it down. Octet rule. What's that say?
8 electrons.
Maximum in the outermost shell is 8. Alright, so now, first shell, when we first start filling this up, how many do I have there? 2, right? That's okay. Then I go to the next one. How many do I have here? 2. In the outside, just the outside shell, 2. And then I put in 6 more. Now how many's in the outside shell? 8. I don't have a problem because that's all that shell can hold. I go to the next shell, the third energy level. I put 2 here. And then I put in the 6. How many's in the outside shell? 8. I can't put any more in that shell. So where's the next 2 go?
4.
4s2. How many's in the outside shell now? 2. So then I go back and then I can put in 3d10. Not the outside shell anymore. Right? It's not the outside shell because the 4s2 is the outside shell, right?
Yes.
And if you follow this pattern, the outside shell will never have more than how many in it? 8. It's set, this chart's set up so you'll never have more than 8 electrons in the outside shell. That's what's nice about using it. Because you'll never make that mistake if you just follow that pattern. Questions on that? Okay. So I've already written these down, so I'm gonna write down, write them down real fast. So the first one is hydrogen. Oh, I'm happy with the color, okay. Hydrogen, 1, 1s1, helium, 2, 1s2, lithium, 3, 1s2, 2s1, beryllium, 4, 1s2, 2s2, boron, 5, 1s2, 2s2, 2p1, nitrogen, carbon, maybe, carbon, 6, 1s2, 2s2, 2p2, nitrogen, 7, 1s2, 2s2, 2p3, oxygen, 8, 1s2, 2s2, 2p4, fluorine, 9, 1s2, 2s2, 2p5, neon, 10, 1s2, 2s2, 2p6. How many's in the outside shell? 8. All right, so then we move on to sodium, number 11. So here we go, 1s2, 2s2, 2p6, 3s1, is that right? And then what is it, magnesium,
12 electrons.
number 12, is that right?
Yeah.
Yeah, 1s2, 2s2, 2p6, 3s2. All right, the next one's aluminum, number 13. It goes 1s2, I've done all these, right?
Yeah.
1s2, 2s2, 2p6, 3s2, 3p1. Then the next one is silicon, number 14. 1s2, 2s2, 2p6, 3s2, 3p2. Next one is phosphorus, 15. 1s2, 2s2, 2p6, 3s2, 3p3. The next one's sulfur, 16. 1s2, 2s2, 2p6, 3s2, 3p4. What's these called? Electron
Configuration.
Okay. Does everybody understand?
Yes.
At least you should understand where I'm getting them at. I'm just going down that chart every time. I just know them. I don't have to look at the chart. All right, then the next one is number 17, chlorine. It goes 1s2, 2s2, 2p6, 3s2, 3p5. Next one's argon. Number 18, it goes 1s2, 2s2, 2p6, 3s2, 3p6. How many's in the outside shell? 8.
8 still.
How do I figure out the outside shell?
Adding the less.
3. That's the biggest number, right? I add all the electrons up in the highest number. That'll never be greater than 8, the highest number. Okay, so now the next one, well, the third energy level can hold 10 more electrons, is that right? D10. But octet rule says the outside shell can hold no more than 8. So the next one I look at is potassium number 19. I'll do this in red. So I'll write it out. I go 1s2, 2s2, 2p6, 3s2, 3p6. It's not going to be 3D. It's not going to be 3D. It's going to be 4s. Everybody sign the roster?
Yes.
It's going to be 4s1. Then the next one, which would be calcium, number 20. One S2, 2s2, 2p6, 3s2, 3p6, 4s2. Then the next electron for scandium, number 21, Sc21. No, I'll change that back to black. Sc21. It goes 1s2, 2s2, 2p6, 3s2, 3p6, 4s2,
3D1B.
if you look at the chart, the next one fills up to 3D, right?
Yep.
3D1. So, but now what's the outside shell?
2.
This is the outside shell, right? 4s2, there's 2 electrons in the outside shell. So now I can go back up and fill the inner shells. Weird? Yeah. It's strange. Alright, so electron configurations. Next thing we're going to look at is what we call the Lewis structure. This is where it's more important. And it, you know, in a few minutes when I go with the periodic chart, it's all, if you get a kind of a concept of what I'm talking about, it's all going to make sense. It tells you all this right on the periodic chart. So now the next thing we're going to look at is what we call Lewis structures. I'm going to take the symbol of the element, for example, hydrogen, and I'm going to write H down. And then I'm going to use little X's or dots or little circles or little stars or whatever you want to use. And I'm going to put the number of electrons in the outside shell. Whatever the outside shell is. So for hydrogen, how many electrons does it have? So I'm going to put 1 dot there. gonna switch around, I'll use X's and dots and circles and stars, because right now it doesn't make any difference, but when we start making compounds and looking at it, yeah, I wanna know where the electrons come from. So it'll make a difference then. So helium. Helium has how many electrons in its outside shell? 2. So I'll put 2 X's. Then I've got lithium. How many electrons does it have in its outside shell? 1. So I'll put Li with 1 dot. Beryllium. 2 in its outside. Remember, just the outside shell. So I'll put Be with 2 dots. And then I've got boron. How many does it have in this outside shell? 2s2, 2p1. How many electrons in the outside shell? Remember, we're talking about the outside shell. 3. 2s2, 2p1. That makes 3, right?
So how come on lithium you only use the 1 instead of
Outside
1s2?
shell.
Oh,
The numbers there.
the numbers from the outside.
Outside shell, the biggest number. The biggest number. I'll do that again when I get down here a little farther, and I'll highlight it more. So boron would have B with 1, 2, 3.
What's the difference between the dots and the X's?
Nothing.
Nothing yet. Not until later.
Just practice getting used to it. Doesn't make any difference what they are. It doesn't make any difference. When I do, okay, so I do water. Oxygen has 6 electrons in its outside shell. 1, 2, 3, 4, 5, 6. Hydrogen has how many? 1. I want to know the difference. See how I use the X's and the dots? The 2 X's are represent, each hydrogen gives me 1 electron, that X. And oxygen already has 6 electrons, that's the dot. So when I start putting them together, X's and dots, they come from different elements, different atoms.
I was just wondering if you put the 2 X's to the right of the helium, wouldn't one go on like the top and one go
I'll
on
talk about that more,
Okay.
yeah. Actually, for some time, when we're talking about some ones that have two electrons, usually we just put them together. So when you have 4, we start spreading them around
They're all on each
on
side.
each side. Yeah, I'll talk about that. Yeah. I just don't have much space right there either. So,
Okay.
all right. So now carbon. How many electrons in the outside shell?
4.
4. That's because I got 2s2, 2p2, right? So here, I'm going to do this for carbon. I'll write carbon. I'm going to put a dot here, a dot here, a dot here, and a dot here. And I'm going to erase the top one because it's touching. That's the way we prefer. Like electrons have what charge?
Negative.
Negative charge. Do they like each other? Typically, no. So if you have a square, a cube with no front and back, a square. So I'll put electron here, electron here, electron here, electron here. So they'll be as far away from each other as possible, kind of. We'll even get into that in more detail too. So now the next one is nitrogen. How many electrons does nitrogen have in its outside shell? 5. So I'll go 1, 2, 3, 4, 5. I guess when you get more than 4, they have to start being together, right? So the 2 together, they can be on the top or bottom, right side, left side, doesn't make any difference.
So your question would look like, what is the, what would the question look like on the test for the,
Write the electron configuration for nitrogen.
Yeah, like
Lewis structure?
Well, both of them, right, electron configuration or right to Lewis structure, yeah.
Okay, but for helium, if we put the two dots not next to each other, would that
That'd be good too.
Oh, for
You know,
sure.
I'm gonna be ecstatic if you get the right number. I'll be ecstatic.
You don't care how we draw them around it?
As long as you get the right number, I'll be happy.
Okay.
Oh my God, you can't imagine what I see. I know none of you do that. That's my class in my semester. No one in here will do that. I got total confidence. Next one is what, oxygen?
Yeah.
How many X's and dots?
6.
Okay, so when I do this, I usually start out and I go 1, 2, 3, 4,
And then
5,
stack it.
6. Just to pull around like a cube or a square. Next one is fluorine.
7.
So it'd be fluorine with 1, 2, 3, 4, 5, 6, 7. And the next one is neon with
8.
8. 1, 2, 3, 4, 5, 6, 7, 8. Next one is sodium. How many?
7.
1. Because the 3
Outside
has
shell.
out. Yeah, 1.
Next one's magnesium.
2.
Mg
1,
1, 2. So when you got 2, you have a tendency to put them together.
2.
Aluminum.
3. 8.
1, 2, 3. Next one. Silicon. 1, 2, 3, 4. Next one, phosphorus. 5. 1, 2, 3, 4, 5. Next one, sulfur. 1, 2, 3, 4, 5, 6. Next one, chlorine. 1, 2, 3, 4, 5, 6, 7. Next one, argon. How many? 1, 2, 3, 4, 5, 6, 7, 8. Next one, potassium. Next one,
1. Okay.
calcium.
2.
Next one,
2.
oh, we don't do those. It'd be 2.
See?
Alright. Okay, so now we're gonna look at something else going along with this. What does hydrogen, lithium, sodium, potassium all have in common? You weren't supposed to do that. I didn't hit erase. I don't want that either. Throw me off here. Come on. 1s1. This one. This one. This one. I could also do this too. No, I didn't mean to do that. Damn it. You ever talk to yourself?
Yeah.
Okay, I thought it was just me. So what was this one supposed to be? Ag,
HC and then
2.
2.
Lithium. There, that one. and this
One
one.
electron.
What else? Is there another one?
Yeah, for K.
Potassium.
Yeah.
They all have
One
one
electron.
electron in their outside shell, right?
Yeah.
Yeah.
And then if I look at helium, how many? Two. And beryllium, 2. And magnesium, 2. And calcium, 2. Right? How about if we look at color? I'll go to blue. How about fluorine?
It has 5.
7. And how about chlorine? 7, right? They all have, there's a pattern there. And it keeps going. I guess it's time to go over there and look at that thing for a while. Yeah. So, periodic chart. This tells you everything I've given you so far. It's all right here. The first thing we talked about is the atomic number, right? That's the order on the periodic chart. That's what makes an element what it is. Hydrogen is a 1. Come all the way over here, helium's a 2, lithium's 3, 4. Everybody follow that? That's the order. The mass number is really not on here. But the atomic number is. The atomic number is, but the mass number is not on here. The atomic mass is on here. Remember, that's the average of all the isotopes of a given element, weighted according to their abundance. In other words, that's the number that has a decimal point. When you're trying to figure out molecular mass, you use the atomic mass. That's the number that has a decimal point. I will take off points if you don't do it to the nearest 10. If you use atomic number, can you do it to the nearest 10?
Yes.
Yes.
No,
Oh, wait, no.
because it doesn't have a decimal point. Right? Atomic number doesn't have a decimal point.
That's right.
Everybody see that? I did that. I used to do that once in a while. But if you do it, I trained myself, I do it to the nearest 10. So I don't make that mistake anymore.
So don't say like the exact molecular mass, even though it's a very exact number.
No, still do it to the nearest 10. Every one of the atomic masses up there have to the nearest 10. I don't think you can find one that doesn't say point something, 0 or whatever. Or maybe some of the ones, rare ones down here might, but some of them, yeah, like these don't, but the ones we're gonna be working with do. And they would too if they knew more about it. So everything up there, like strontium's 87.6, too. You can round off 87.6. That's perfectly fine. That's what I want you to do. That way you won't lose points for doing that. All right, so now, if we look at the SP, D, and F parts, if you kind of take this up, look at this, but if I took helium and brought it right here, those represent S1 and S2 electrons. All these have, I just showed you hydrogen, lithium, sodium, potassium are all S1 in their outside shell, right?
Yeah.
And all these are S2 in the outside shell. These represent outside shell electrons that are S1 and S2, the S electrons. And then the next one we fill up is way over here. P1, P1, P2, P3, P4, P5, P6. Those are filling up the P electron. And our outside shell is P electron. And so we call these the P electrons, not helium, but helium would be over there with hydrogen. The only reason helium is over here is because it acts like a inert gas. It has the same properties. If it had more than 8 electrons, it would probably have 8 electrons in its outside shell. And it would be just like the rest of these. It is like it. All right, so then we get to these down here. If you count these here, there's 10 of them. Those are the Ds. They're filling up the D orbits. Right? D D1, D2, D3, D4, 5, 6, 7, 8, 9, 10. And then the last ones are the F's down here. If you count that, that's 14. Why are those down there? Why'd they pull them out?
Not enough room.
That's right, make the chart smaller, so it'll fit on one sheet of paper. When I first started teaching, someone did a project, and they took the periodic chart, they had one of these, and they cut it open, right here, stuck the F's in there. It was a big old chart on a big old chunk of plywood. I kept it for a long time in my garage, because we threw it away at school. And finally my ex said, "You gotta get rid of that." Do I have to, really? So you know what happened, obviously.
Can't touch it.
I got rid of it. Okay, so now, order of filling. So we start out and we go 1S1, 1S2, right?
Yes.
Then we go 2S2, 2P6, is that right?
Mm-hmm.
Then we go 3S2,
Oh, I get it. Okay.
3P6, right? And what's the next shell that fills up?
4.
There's 8 in the outside shell, but the S level can hold 18, so the next one.
4S2.
Our Chem rule says the maximum in the outside shell is
4S.
8. And so we put 2 in the 4S2.
4P6.
And then you fill up the 3D10. Well, the periodic charts lined up exactly like that thing I showed you. Because this is the third period here, right? But the 3D is down 1. They moved it down 1. You follow me?
So what would manganese be? And then,
Make here,
yeah.
it's what, 5D? 1, 2, 3, 4, 5. There's some discrepancies. I might as well talk about those. There's a few discrepancies right along in here. And right over here, maybe a little bit. And there's a little bit right here. And a little bit right here. Are we gonna do those? No.
No.
We're not gonna get into the weird stuff. But anyway, if you just look at manganese like we have it listed here, it's 3D5. 1, 2, 3, 4, 5. But that's 4S2, 3D5. And it keeps on going. You do the 3Ds, then you do the 4Ps, then you do the 5Ss, and then you do the 4Ds, alright? Then you do the